So are you guys real SportWit MCAT students?
Hell yeah!
Okay.
Hi guys, so let's talk briefly about radian measure. So if you're talking about radians, basically the idea is this. You take a circle and let's give them some radius. So let's say like the radius is 2 meters, okay? Right. And if you imagine right here that we basically have like a paint and we start to open this guy up, and as we open him up, we're painting the outside. Do you guys agree that at some point we're going to open up so much that you literally get 2 meters, or in this case, 1 radius on the outside, right? The angle that you need to get that isn't called 1 radian. Okay? So the way to think of it is this, right? 1 radian is literally painting 1 radius on the outside. So if we were to open up, say, 2 radians as an angle, right? That means you've opened this sucker up so much that literally on the outside, you've painted 2 radii. Not too bad, right? So I get it. 3 radians, you paint it on the outside 3 radii. 4 radians, you'd open up 4 radii, etc., etc. Okay? So now what I want to do is connect this to degrees. So you know the circumference is 2 pi r, right? If the equation instead had been something like this, so let's say the circumference were given by 2r, that literally means you can wrap 2 radii around the outside. Okay, but you know it's 2 pi r, so what does that mean? You can wrap 2 pi radii around the outside. But you know that every radian gives you 1 radius, right? So how many radii fit around that circle? 2 pi. Therefore, that means there are 2 pi radians in that entire circle. Okay, but you also know there are 360 degrees, right, going all the way around. So now we just put this together. 2 pi radians is 360, so pi radians is 180 degrees. And this is generally how you convert from one to the other, okay? Everything we do in calc, though, is really going to be based on radians because radians make life easier. In fact, when you take the derivative of something like this, right, you know that you get cosine x, okay? Or if you haven't seen it in the course yet, you definitely will, okay? But this equation, believe it or not, only works if you're talking in radians. If you did in degrees, you would get something similar, but there'll be this compensating factor, this constant in front, so you can basically convert from radians to degrees. Okay, no big deal. One more thing about radians, they allow us to very easily connect angle here to basically length on the outside, or arc length, okay? So how does that work? Again, we just use the definition. So say you have 2 radians, right? What that means is you've opened up so much, you've painted on the outside 2 radii, right? And here we'll do a little bit of dimensional analysis. So if we had 2 radians, right? What does that mean? Well, every radian, so 1 radian, right, is worth what? It's worth 1 radius on the outside. And in this case, the radius is 2 meters. Does everybody agree? And the units will cancel out. And it also makes sense in words, right? If you have 2 radians and each radian is worth 2 meters, then definitely you have 4 meters. So now we're just going to put this in general format. So we took our radian measure here and we multiplied by the length of a radius, right? Which in this case would be 2 meters, but I'll say in general it's going to be r, right? And this actually gave us this guy, which is that arc length along the circle, okay? No big deal. So traditionally, a lot of people call that S. You can call it whatever you want. Okay? And we're going to use this idea when we look at that special trig limit, which is about to come up. Okay, so what I want to do now is look at a special trig limit, and this special trig limit is sine of theta over theta as theta approaches 0. And if you want to see that formal version, you can go to the MAD videos. But for this version, I just want to keep it really mellow and try to do it intuitively, okay? So here's the idea. Let's say you have some angle here, okay? And just to get a feel for this, let's imagine that you're on a circle of radius 1, okay? Something like this. All right, now if you go back to the old trig days, right? You can drop this height here, and you can get this guy right here. This guy happens to be the radius here, times sine of theta. If you're rusty on that, let's just do that really quickly. So say this is our hypotenuse, right? And this is our angle theta. Do you remember that sine of theta? Well, let's call this y. You remember that sine of theta is the opposite over the hypotenuse. So y over r. So now all I'm going to do is multiply across and get r sine theta is equal to y. Okay, and that's exactly what we have here. Okay, no big deal. But now, because we're on the unit circle, this guy is 1, so this is 1. So really, we just get sine theta, right? Okay, So let me get this straight. This pink line here represents sine theta. Okay. And in that video you just saw, hopefully, we talked about radian measure, right? So we're going to measure everything in radians, and this is going to be really nice and pretty, because if the radius is 1, and we wanted to get here, and you open up some angle theta, and we wanted to know what is this arc length here, right? Now let's call that guy S. We said that S is equal to theta r, right? But in this case, r happens to be 1, so really all we're going to get is just theta, right? So that arc length is theta. So this arc length is theta, okay? So let me get this straight. When we look at this limit, what we're really seeing up top is the pink guy, and what we're really seeing down below is the yellow guy, okay? And you can see visually, as this thing gets smaller and smaller and smaller, in fact, I'll try to draw it. Let's imagine it does this, and then it does something like this. Do you agree that right now the straight line and the curvy guy are a bit different? But if we go down here, notice that the straight line and the curvy guy aren't so different, and if you go down here, they're even closer. So does everybody agree, as you bring this down and down and down, this guy and that guy basically look the same? So you can imagine intuitively that as this guy approaches 0, the pink guy and the yellow guy approach each other. So what you're really looking at is some value over itself, which is, of course, 1. Okay? So the limit of this guy, this whole thing, right, as theta approaches 0, is actually 1. So this is the intuitive version, so you can visually see really what's going on. Of course, we could do the formal version. That basically, it's somewhat similar, but what we end up doing is constructing a triangle here, trapping it between trig functions, and then using the squeeze theorem to prove that it's going to work out. Well, anyway, hopefully this works for you. If so, then we can move on to some more limits, and then we'll be able to move on to derivatives.